Hey, what's up, guys? So, a lot of times when you're working with Bluetooth Low Energy, you're working on a project where you need to run off of a battery for a very long time. So, low power design is one of the most important things. So, I thought I'd make a quick video here running through the different low power modes of the Anaren 2737 Bluetooth Low Energy module that's on the BLE board, right? And you might be wondering why I'm in front of this window, and that's because I'm actually running some experiments for a future project that I'll make a video on using a solar panel to power the BLE board. In fact, I'll give you a little sneak peek into the whole project. Let's take a quick look. So yeah, this is a very simple setup here. I just have a cheap, tiny little solar panel here, which through a diode is charging up a 470 microfarad big capacitor here. And then on this board I have a tiny little linear regulator bringing that voltage down to 3 volts, powering the BLE board. And that's all there is to it. I'm just running some experiments right now. And right here, what you see, I'm able to power the BLE board. We have it on a mantle here, so it's able to be powered. Obviously, it needs direct sunlight. We only have a capacitor in the system. I could make this into a full, charging thing with a lithium battery out there and all that, and maybe I'll get into that someday as well. But yeah, what you see here powers the board, and I'm able to connect to it. So I'm just going to launch my app here, scan. There it is, and I'm able to connect to it and blink the LED. So hopefully that was all on camera. But yeah, so that's just a simple little project here I'm working on, and I'll show you the code for this as well here in a second. So there you go, that's just a simple project. So now let's jump into all of the different low power modes that you can put the BLE board into. Okay, so we've got the BLE board sitting on the bench here, powered up from the source measure unit at 3 volts. Now, one of the things to keep in mind is that I'm not going to show you the current consumption in real time using an oscilloscope. So I'm just going to show you what the current draw is kind of by glancing up at the meter here. So when you're designing for low power though, you really want to look at your current in real time so you can get an average current draw over a period of time. So that'll help you determine how long you can run off of a battery. But for this video, I really just want to work through the different low power modes and kind of give you an idea of what the current draw would be, or the idle current, right? The sleep current. So anyway, just keep that in mind, and let's jump right into it. So the first thing I want to do though is baseline the module. Let's see what the current draw is with really nothing running and no low power sleep mode enabled. So you might remember the last project we did with the simple LED toggle. So we just had a button there and then a toggle GPIO function. And over in the code view, everything's pretty standard here, nothing special. We're running the no sleep power mode, okay? And then there's our function there to toggle it. So watch that video for more information on how I got all this set up. But we're going to actually start here. So this is what I have loaded into the module right now. And you can see we're not connected to the board. Let me make sure of that real quick here from the app. Actually, I was connected. So here is the smartphone. We'll go to the apps screen. In case you didn't know that, you can actually go in and select whichever app you want, which is really cool. So you can actually pick out and keep all of your apps here in a list view, and then whichever one you want to use, you can just pick it. So GPIO toggle, we'll open that. Okay, and then we go to scan, and there it is. But before we connect to it, let's take a look at the current. So you can see we're at about 3.5 milliamps or so. Okay, so we'll connect to it, and there we are. Now it kind of shot up to about 4 milliamps or so. And we can, of course, toggle the LED. So there's our baseline with no power mode. And one of the things you might be wondering is, well, why would you actually want to be operating in this power mode? And the real answer for that, and this was a question I had as well, and this is the great thing too, I want to show you real quick, is if you go to the atmosphere.anaren.com and go to the forum, you can post these types of questions. In fact, I just did post this question where I broke down all of the sleep modes here and what I was witnessing, and within a day I got a response from somebody at Anaren where they basically confirmed everything that I saw during my test and answered all the questions I had. So there's a lot here, but basically the reason you might want to operate in no sleep mode is when you need high accuracy PWM. Okay, so and they actually have all of this broken down up in their wiki here. So you have different sources for the PWM. So if you think about it, you know, you might need no sleep would mean the processor is always on running. Okay, so if you needed that highly accurate PWM output to one of your pins, you would want to run off of that high-speed clock, right? So you can actually do that by going to project settings and then down, where's it at? PWM clock source. So you could select the PMU clock or the LHL clock. And that is all explained here. But if you're not using PWM, then there's no reason to use the no sleep power mode. So I'll get into that in a second, but just wanted to mention that real quick. Okay, so the next power mode I want to get into is, if we go here to set mode, I want to go into sleep mode. So I'm just going to do this. And the other thing too we want to do is make sure that we set all of our unused pins either high or low, right? So I'm just going to jump over to the wiki real quick for the board that I created. And it's right here. And I have this nice graphic here that we can see all of the pin names, so all the gray pins there, and we can set all of those. And I'm going to configure all of those as outputs and then drive them low. Okay, so there we go. We've got all of those pins set as output and then driving them low. So it's very easy to do this. You know, AIR GPIO set mode 15 as an output push-pull, and then we're going to force it low that way. So I go through all the pins, but remember that these are dual bonded pins, so I'm just setting P11. Here's a dual bonded pin. I'm just setting P11 low, not both P11 and P27. Same thing with P14 here and P8 over there. So so that's what I'm doing there. And then the other thing too is I want to get rid of a couple of these things because we're not using these functions, so we don't need the UART, we don't need the I2C, we don't need the buzzer, and we'll set the mode there to sleep. So there we go. Let's go ahead and load this up. I'm going to build it. Okay, we'll go ahead and hit the reset button on the BLE board and hit program. Now I'm going to remove the USB to serial converter every time when we take a measurement just to make sure that there's no current leakage into the converter inputs and outputs. Anyway, okay, so here we go. We have that code loaded up. And now when you look up at the source measure unit, you can see that we're no longer pulling 3.5-ish milliamps. Now it's dropping way down there to about 30 microamps, in fact. Okay, so you can see we're getting about 30 microamps of idle current between transmissions, advertisements. So you can see we do see some spikes there. It goes from about 30 microamps, and we're seeing it go up to like maybe 5 small little spikes. But of course that, let me go into one other thing over here. So that will... Okay, so you can also modify what that transmit current is going to be. So when it wakes up and advertises, you see these little peaks in the current draw, and you can change that by lowering your TX power level. So right now it's at its max TX power level, which is 4. You can lower that down to 0 if you want, or even lower. Check the data sheet on that, but I'll leave it at 4 for right now. I'm also running the interval timer at 1,000 milliseconds, which is that max, and those functions are here. So that's the great thing about this power mode is that all of these functions are still called, and you can still connect to it. Everything still works. So there it is. We can connect to it and blink the LED there. So. But still, even when you're connected to it, you can see it's going to be in constant communication with the smartphone more frequently, but you can still see that it drops way down in between those transmissions. So that's pretty good. One thing to keep in mind too, though, just about Bluetooth low energy modules and what's out there, the Anaren part is not the lowest power part out there, obviously. There's some other manufacturers that make lower power devices, so just keep that in mind. Okay, so that kind of explains the just the first sleep mode, and this is probably my favorite. So if you're going to work with the part, I would start with this sleep mode unless you needed that highly accurate PWM output. Okay, so now let's get into deep sleep mode. That's the next one here. So to get into deep sleep mode, I'm actually going to call up this other app that I shouldn't say the app, but this program that I already created. So it's the same kind of thing here where we have a button that toggles a GPIO pin, but we've got some other stuff going on in here. So let's just walk through it. I'm gonna just expand that out a little bit here. So what we got in here in the setup here is all the same stuff. I've got an example here on how to set up an interrupt pin. So I did have, and I was experimenting with this, you could use an interrupt here to wake it up from this next sleep mode I'm going to talk about. So this is would set up a interrupt on pin 2. It calls interrupt function, which is the function that is called when it's interrupted, and then what type of interrupt it is. So in this case, it was a falling edge interrupt. And then you see way up here at the top, I have that function here that is called for when that interrupt occurs. Okay, but anyway, I'm not using it here. I'm just putting it in there as an example. Okay, so then we still have everything commented out, all the other functions, and then all of the unused pin set. And then I'm setting it for the standard sleep mode we talked about. We've already talked about, okay. So this is when it's it only sleeps in between BLE activities. Everything operates normally. Okay, so we're at about 30 microamps in between those activities. We still have the toggle here. But what I did here was in the interval function, I added some code here. And you can see there's some variables up here. So we have a BLE connected Boolean variable here, which is false right now. We have an interval counter integer, which is set to 0. Now, when it is connected, I will set the BLE connected variable true. So this function is called the first time we connect to the part. This function here is called when we disconnect from the part. So BLE disconnected, or BLE connected is equal to false in that case. So in the interval though, this is called every 1000 milliseconds. So once a second this is called. And what I'm doing in here is first checking to see if that interval counter is greater than 3. And as long as we're not connected, BLE connected is equal to false, do this stuff. But before we get into that, let's see how the interval counter could ever be greater than 3. So if we are not connected, if we are false, flash the LED here and increment the interval counter. Okay, so very simple code. So after 3 seconds, because we'll be at an interval counter of 3, we want to, or I should say, yeah, it'll be 0, to then to 1 to 2 to 3 to 4, okay? Then we're at this point here, and we want to set the deep sleep interval to 5,000. And what this does is it sets a timer, okay? So for 5 seconds, and this value here determines how long it will go into this deep sleep state and then wake up. Okay, so then we go and call, we do a set low power mode of deep sleep here now, okay? I know, I love the names here of all these modes. I'm going to expand this out here so we see we're at deep sleep here. And what this does, as soon as this is called, it will sleep for 5 seconds, okay? And it will be a very deep sleep, low power deep sleep. When it wakes back up, it does not pick up right here, but instead it will reboot the entire processor. So it'll pick back up right at setup. Okay, so that's kind of a downside to this sleep mode, but what you can do here and what this does is that it sleeps for, or I should say it's awake for 3 seconds, advertising, letting you connect to it. and then it sleeps, deep sleep, it sleeps for 5 seconds. It does nothing for those 5 seconds. So hopefully that kind of makes sense. And then it wakes back up and restarts that. So it's a way to extend your battery life, because now instead of advertising all the time, maybe you're not going to want to, connect to it right away. So instead you'll have to wait for this 5 seconds here to elapse to when you would see it up in your scan screen here. So anyway, that's just an example of how to use this mode. So let's go ahead and load this program up here. Okay, I've got that loaded up. And with this sleep mode, it's even more important to remove the USB to serial converter. The reason for that is because when it wakes up from that deep sleep, it's going to reboot. And remember, when it reboots, it's checking to see if the USB to serial converter is there. And if it is there, it goes into programming mode. So we need to make sure that we have this removed in order to run this mode. So let's go ahead and I'm just going to reset that. Okay, so right now it's going through. You can see it's blinking the LED, and then it goes into its deep sleep. So check it out for 5 seconds, and I missed it. We'll catch it again here. Okay, so it's flashing the LED, and then bam, it goes into this deep sleep. Look, 10 microamps. Okay, so it'll sleep at 10 microamps for 5 seconds, wake up, flash the LED, and then go back to sleep. So let's see, I'm gonna load that app now here. I have to go to low power, open that up, scan, and we have to wait for it to wake up. There it is, it wakes up, and then we connect to it. We have to hurry up, and then there we go, and we can connect to it. Now, when it wakes up and when we connect to it, remember that in the code here, what I've done is as soon as it's connected, we set this variable to true, okay? And it holds on to that. So every time the interval is now called, since BLE connected is true, this part here, this if statement will never occur. Okay, so that's just kind of a cool way to do it. And this is actually the code that was running on that little solar panel test that I had over by the window. The other thing to keep in mind is that when this wakes up and it reboots, you're going to lose all of your variables that you were working with. Okay, so if you needed to save any of that before going into sleep mode, you save those into non-volatile memory. And look at this. So I got the response from Anaren here, and they've given all of the links to how to do that. So that was one of my questions. Okay, so the next mode is, and I'm just going to quickly show you the next mode here, and we're going to go back to the GPIO toggle demo here, and I'm just going to put it into power off mode. Okay, so, and I'm just going to put that in the interval here. So this is going to just kill power to the part, and I just want to show you what the reading is. So I'm just going to go ahead and build this real quick. Okay, so now I have the last power mode here, which is power off. I skipped over very deep sleep here, and that's because that is not yet implemented. So it actually doesn't do anything yet. The power off here will put it in its deepest sleep state, but it's not really technically a sleep state because it's completely powered down the module. And according to the forum post here, they said that there is no way to wake it up from this mode. However, I was able to wake it up using a GPIO interrupt, so they're still looking into that to prove it out. But yeah, if we look at the power here of this mode, you can see we're at 1.8 microamps of sleep current. So I guess the recommended way to wake it up from this mode would be to yank on that reset pin and then wake it up. Okay, so what you might do with this mode is, if you had like an accelerometer or some other device that gets some kind of feedback from the environment to wake up, maybe even a push button, you could use that to wake it up, connect to it, do whatever you want to do, and then it kills its own power and sits in this low power state. Now, if I had a host microcontroller or some other way to control the power to the part, like actually physically from a digital pin off of like an Arduino or something, I would actually power this module from a GPIO pin so that I can just completely kill power to it, right? So anyway, that's another option. But this kind of goes through some of the sleep modes of the part, and hopefully that helps you out. So just a quick video there. Well, maybe not so quick, but anyway, that's the video. Thanks for watching.